like to introduce you to the founder and CEO of Varon Vehicles Corporation, Felipe Varon.
Thank you very much. Thanks. All right, so we're going to be spending the next hour talking about urban air mobility and flying cars. It's the urban mobility problem, and most of us know about this problem because of the congestion, right? The traffic and the gridlock. But it turns out that globally, this problem has many more branches. So the way we see this working is in the following manner. Whenever you need to go from your origin to your destination, we want you guys to be able to reach your cell phone, go to our app, and request our service. Then the system will tell you to go to the nearest Varon Vehicles vertiport, where a flying car will be waiting for you. You'll board the car with a driver on board, and then you'll fly at a low altitude over the city and go to the Varon Vehicles vertiport closest to your destination. And then after that, you'll leave the system and again, use one of the intermodality ways to reach your final destination. You can get a sense that we have a first and last mile problem, right? So we're relying on potential partners to solve that problem, to actually make this a complete on-demand service from origin to destination. And the value that we're proposing comes in shortening that time of transit. Usually when we think about aircraft, we think about, first of all, air traffic control. We want to be able to share the airspace and communicate with a control center. Right. Then usually you think about having a pilot. You want to have a high skill level operator piloting the aircraft. Third, you talk about efficiency. Of course, you want to have, when you talk about a fixed wing aircraft, you talk about the airfoil, and you want to be as efficient as possible to use the least amount of energy to do those trips, right? And finally, the altitude. Usually when we think about the aeronautics industry, we talk about high altitude. Why? Because the typical aircraft, they're safer at higher altitude. We think that urban air mobility, flying cars, if you will call them that way, or flying taxis, well, they're a new box. They're a new industry. And we have circled our entire architecture around a new set of paradigms, leaving those other paradigms sort of like in the background. Remember about the problem? Well, that takes us to think about who our customer really is. It's the regular Joe. It's not aircraft savvy people. It's not the adventurous guys. It's just the regular Joe in the street, the person who wants to go from one place to the other and is thinking about other things in life. Well, first of all, it's the fear of flight. We know, and we have done our research, and we've found that people are actually scared of flying. Second is the cost. We have to be viable. If we're not viable, we don't exist, right? So one of the things that we've looked at is taking the pilot away from the equation, from the financial equations, the fixed cost structure. So we want to take away the pilot, but we still want to have the operator on board so that we can break that fear barrier, right? So you want to have people board a car that has a person on board, that people feel that, okay, this guy knows what he's doing. This person has been flying this thing for the entire day, and he's trained and certified to do so. In other words, they're lower skilled pilots. And that circles around to the entire architecture of the vehicle that we've designed and the human-machine interface that we have designed. Third, we have community acceptance. So community acceptance is very important. Remember, we're trying to set up a system that is going to be occupying space over a city. And this is everybody's space. So that's where we approach things like noise, generating employment, right? To be able to acquire that community acceptance. And fourth and finally, airspace, right? Airspace. How do we deal with being able to put a system of multiple flying cars into an already congested airspace, right? And how do we go about regulations, right, that need to keep us safe while operating in that airspace? But we know that eventually we need to set up a test system. Nobody knows in reality how urban air mobility is going to actually operate. What are the key performance indicators that we need to take into account and that we need to know about? Of course, what are the good things, but most importantly, what are the bad things, right, that we don't know about yet? So as you can see, we're developing a transportation service. It's not just about the flying cars themselves. We're developing our vertiports, the airspace integration, the traffic management system of those. How do we orchestrate that traffic of cars within those airspaces that we're occupying over the city? and of course all the complementary assets that we need to operate and monetize the system customers. And we have devised five verticals in our company, and that's these five. Of course, the flying car development itself, we have our own proprietary flying car that we've developed around those paradigms that you already know about. Then the business units, how do we operate and monetize the system? What's our business model? The urban implementation, it's very important part. How do we model the mobility problem? How do we model our entire business put into a real city, not a hypothetical city, but real, model with real data on real cities. An app environment, which means that window with the customers, and that's an entire vertical on its own. And finally, the insurance and the regulations part. In essence, what we want is to be viable today. We don't want to build a system that is going to be available in some faraway future. We want, and we know that flying cars can actually be done in the near term because the technologies are there. And the costs allow us to think about actually having this being done in the near future. Now, in order to be viable, we've identified two main needs. As I already told you, one of the main ones is breaking the fear barrier. And we intend to do that in two main ways. Number one, having an operator on board, right? And number two, flying as low as possible. In other words, not obligating people to be flying on a very small aircraft at high altitudes, because that's simply scary. We think that we need to fly as low as possible to make it comfortable for regular people. And second, is the friendly access and implementability into cities, which means the employment part, the low noise, the other factors that I told you about. So in order to achieve those two things, we have that list of characteristics. So in other words, we're flying at low altitudes over the low airspace over the cities at relatively slow speeds, right? Because we don't need to go very fast in order to cut transit times from literally hours down to simply minutes. We want to have a driver in control. So we're taking away all the futuristic approaches like artificial intelligence, blockchain-based networks. We're not adding any of those layers just now into our system. That's something that, in my opinion, will come, but will probably take decades to come. And I want to point out here the confined ecosystem. So we're creating this architecture for airspace integration and traffic management. We'll talk about that in a bit. But in essence, that is very confined, very predetermined. In other words, virtual lanes that are pre-assigned and predetermined over through which the drivers will drive their cars. It's not about. So let's talk about our car, the V200 series. That's a picture of our flying car. As you can sense, we don't have any wings because we don't want to fly high. We want to fly low. And drones, as you may well know, allow that type of flight. In other words, what we call high-level commands. Go up, go down, auto land, auto takeoff, no artificial horizons, no crazy dials like in a cockpit. The human-machine interface that we have on board is just like that of a regular street car. And our vehicles are actually they're composed of four subsystems. We have what we call the chassis, otherwise known as the airframe, which is a fixed chassis. There's no moving parts, no mechanical system, pneumatic systems, or hydraulics at all, just fixed motors attached to the airframe, which is the propulsion system. Electric motors driven with electronic speed controllers, just simply modulating the power of each motor. That's how we acquire full dynamic control of the vehicles. Third, we have an energy system on board. How do we store the energy? Of course, most people relate to that as batteries, but not necessarily. We've done our research into what's the most viable way to store the energy on board the cars. Batteries have their pros and their cons. Fuel-based systems have their pros and their cons. So that's part of the research that we are undertaking currently. And the fourth subsystem is the flight computer, the navigation, the electronics of it, which, again, being just like a drone-based system, it's simple enough in concept. Of course, not to talk about the redundancy required for certification. We have all the capabilities in our startup to design certifiable aircraft, to test them with test pilots, all the way to manufacturing and support and maintenance of the fleets in the future. So we're talking about. So again, there's nothing simple about aircraft, right? But in concept, you can achieve simplicity, and that highly impacts the financials of the operation, right? From the fixed cost of the vehicles all the way to the supply chain and the operation, and that's a central part, as you remember from the first slides, of our paradigms. Cost. So what we're building are these networks of the city with our vertiports and airspace volumes linking those vertiports. Remember, we don't want flying cars just wandering about all over. We want our flying cars to be driven over pre-established, predetermined virtual lanes, linking those vertiports. So that we've come up with the term urban geodesic. We've coined that term to refer to the shortest path between two vertiports, taking into account the no-fly zones, the city obstacles, the city topography, and known climate conditions. In other words, that nobody else can go in there. No drone, no helicopter, no low airspace route, nobody else, so that we stay away and safe from existing aircraft. And at the same time, to not need to communicate with air traffic control. So these are fixed and permanent airspace volumes. And what happens within those airspace volumes is what we call the traffic management system. Once we have those volumes linking the vertiports assigned, then the question is, how do we orchestrate traffic? How do we make sure that our traffic of multiple cars operates safely? So that's what we call our traffic management system. And we have devised an architecture and have simulated this in reality with real flying crafts to come up with that system. It's a new, brand new approach. So this is what we want to achieve in the end. It's over a city. We want to have a network, sort of like a metro system, right? Like a metro system where we have determined stations and these lanes, but these are software lanes, right? They're not physical infrastructure, but software infrastructure. But the value that we offer comes in between those vertiports. And we're, real data. We're talking about trajectories that could take hour, 15 minutes, hour and a half by regular modes over the city that we're actually estimating on doing in 6 to 8 minutes, right? Trajectories that would otherwise take, in some cases, over 3 hours, that we're talking about doing somewhere between 22 and 24 minutes. And that's taken into account takeoff time, cruise time, and landing time.
I'm curious about unmanned cars. So, obviously we've got driverless cars and how the psychology and how that's been accepted. I'm from Atlanta. We don't have them, so I have no idea. But how is that research or even are you looking at that to see how people are becoming more accustomed to that? Obviously, you chose to put a driver in there or an operator in there.
Right. So it turns out that driving one of these may actually be much, much easier than driving a regular street car. But the regulations for aircraft, remember, this is an aircraft. And we would be and will be occupying an actual airspace regulated by aeronautics authorities, FAA in the case of the United States, and their equivalents in the rest of the countries in the world. So we have to abide by safety regulations, certifications, right? So all those layers for us are future layers, like artificial intelligence, like blockchain-based networks, like self-driven flying cars.
So speaking about safety and so forth, tri-motor type design is a hexacopter at this point in time because it has 6 motors or 3 in it. And what is our fail-safe redundancies and runtime?
But the actual design of the real size cars, they have multiple propellers. And we're talking about over 12 or maybe even 24, right? In the same footprint, in the same body. So there are many layers in the fail-safes, all the way from actual mechanical redundancy with multiple distributed propulsion to the mechanical construction of the system and redundancy in all the subsystems, navigation and flight computers and so on, to the software fail-safes, right? So you can see that what used to be mechanical complexity in the earlier age aircraft is now able to be transformed into software complexity, which allows a whole bunch of layers for safety, right? And also taking, to your point as well, taking a lot of burden away from the operator, which allows us again to talk about a driver or a lower skilled pilot. If this was
My question actually has to do with airspace too. It's somewhat two-part. Are you saying it's over 400 feet to try and get away from the Part 107 rules currently? The Part 107 drone operator rules get about 400 feet. And secondly is, how is this going to work into the national airspace system? And are you trying to work with FAA to work with trying to find a piece of the airspace that this type of flight could use?
The idea that we all have is to provide permanently assigned and permanently reserved airspaces for the manned flying cars, where drones should be kept away from, right? And yes, we're collaborating with the FAA, in constant communication with them, also collaborating with NASA, because the idea that we have is to establish a first system to learn about this. We're breaking ground here. I mean, we're cutting grass as we walk along and making our own path. So we need to test this whole thing out and see how it operates, right? And we're pretty much ahead in many ways. I can tell you that we, as far as we know, we're the first and only company in the world with an actual airspace assigned to us. And we're doing these exercises already with simulated cars, right? But physically doing these exercises at that altitude with that architecture that we have devised for those orchestration of the traffic.
As far as licenses,
Yeah.
are you looking like a light sport type aircraft license, or will you be looking at going through the process to even a different license than that?
So that's a very interesting point, because not long ago, we got a very interesting green light from this country's aeronautics authority, in which they said, you guys are going to generate these new regulations and propose them to us. And that includes not only the airspace integration, but also the certification, right? The certification up, going to the FAR certification requirements, and also to the operator license requirements. Everything. Remember that I told you that one of the big values for us is community acceptance. And part of that is generating employment. We need to generate employment, because what we've done is identified a specific niche. We're talking about low altitude, short range, because the market we want to tackle can be serviced with that type of vehicle. And that's the niche we want to reach.
So how long till we're going to see you flying the vehicle at one of these shows?
I hope to land here in one of those next year. But so I think you mentioned this, which is really, really cool. It's not about the cars. The technology is there. If we had the way to just bring everything into a garage, we can put it together and just have some crazy guy board it and fly it. It's not about that. It's about the difficulty, the work that we have to do. It's not about the cars. It's about how do we create a system that is applicable in an environment that already exists, in a city, in an urban scenario. How do we make it safe enough? How do we have it perceived as safe enough? And it's not about building a flying car in your garage. It's about building an aircraft. And you guys know a lot about aircraft, right? When you build an aircraft, you have to certify it. You have to have traceability. You have to have all the compliance that is involved. So that takes a lot of time. And we are